fortunately, in 8.6, the strategies that I'm going to show you, we've already actually been using. It's just that these types of equations are going to be a little more complicated. That being said, we've worked with some of these types of problems already in chapter 8. So you already have all the information in order to be successful in this unit. We're just going to combine some things together, and that way you'll be able to solve these equations a lot easier. So there's a couple steps I want you to follow, and if you do that, it'll be easier to get these problems successfully solved. The first thing we're trying to do is actually get rid of all the fractions. Again, a rational equation is just an equation with a bunch of fractions in it, and most of those fractions are going to be polynomials, or they're going to have polynomials in them. And we've solved equations earlier this year with fractions, and our goal was to get rid of the fractions so that we could just solve a regular equation with sort of nice numbers. Now, does anybody remember the strategy that we used to solve equations that had a bunch of fractions in it?
Common denominator.
Okay,
Combine like terms.
close. You're on the right track about the
Cancel out the common denominator.
yes, but how?
Make it equal 0.
No.
Oh, make the same line.
Itself.
Say it.
Reciprocal. Itself.
No.
The denominator.
Yes, we're going to multiply through by the common denominator. Okay? So there's several things there that we just need to tie up. Okay? Now, here's the thing with equations, and this only works with equations because there's two sides. If it's just an expression, you can't just multiply randomly through. Because an equation has two sides, and if you do something to one side and you do it to the other side, its values remain the same, it just looks a little different. This strategy will allow us to get rid of fractions. And we've done this earlier in the year with some other types of equations that had fractions in them. Okay, but this strategy will work in this situation as well. You got to find the lowest common denominator and then multiply all the terms by it, and then the fraction should go away. Okay, so then once the fractions are gone, you just solve the equation like normal. Whether it's a quadratic or a linear function, you solve it using any of the strategies we've already learned this year. The one thing you have to keep in mind is at the beginning of the problem, you're going to have variables and denominators. And the only thing you have to watch out for is making sure that none of your answers after you solve your equation turn out to make the denominator equal 0. Because we have to throw those answers out. Okay? So the only thing you have to check for. You go through and solve it, and you just want to make sure that none of those solutions that you came up with will turn the original equation's denominators into 0. Because as we know, you can't divide by 0 because that's undefined. Now, I will tell you that there are other ways to solve rational equations than this. My opinion, this is the easiest way. And so that's the way I'm going to show you. If you choose to use a harder way to do it, by getting a common denominator and adding and simplifying, you can, but I do not recommend it. I think there's more opportunities for mistakes, and if you just follow these steps, you'll be more successful with these equations. Okay, here's an example we're going to go through, okay, and these are the types of problems that you're going to see, okay. Understand how these are different than what we did earlier in chapter 8, and it has to do with the equation. We added fractions like this, okay, earlier in chapter 8, but in a case where we have an equation, we can actually clear the denominators and get rid of all of the fractions if you follow the steps correctly, okay? Now, before we try to get a common denominator, what do we have to do with all of the denominators first? Factor. Okay. So p minus 2, can that be factored?
No.
P squared plus 2p minus 8, can that be factored? Okay. P plus 4, can that be factored? No. Okay. So let's look at this one. Let's focus on this. How can we factor that?
P plus 4, P minus 4. 2.
P plus 4,
P minus 2.
P minus 2, okay? So I can factor that. And if you notice, then, if I'm trying to find the lowest common denominator, remember I want to bring the things that are in common and make sure those are all in there.
That worked out quite nice.
Okay, did work out nicely, didn't it? What is the lowest common denominator here?
P minus
Okay, so if there's one P plus 4, and over here there's one P plus 4, so my common denominator has to have one P plus 4. That covers this one, and it covers this one. It also has one P minus 2, and over here it has one P minus 2. So having one P minus 2 in my common denominator covers this one, and it also covers this one. So what's my lowest common denominator?
P plus 4, P minus 2.
Correct. Okay. So in this case, and you guys showed me on your quiz that you can find a common denominator in rational expression. The same idea is going to be true here, it's just an equation. So once I identify what my lowest common denominator is, I have to multiply each term by it. Okay? And if I do that, and if I found the correct lowest common denominator, then the fractions should go away. If they don't go away, one of two issues. You didn't find the correct lowest common denominator. That might be your issue. Or two, you multiplied incorrectly. Okay?
What are we multiplying?
So, I'm going to multiply this by the lowest common denominator, this by the lowest common denominator, and this by the lowest common denominator. So, here's what that looks out. Okay? Now, I put these all over 1 just to show you that you could write it as a fraction in case we get to the point where we're canceling things. Okay? So you're going to have to insert that next to each term. So that here are the 3 terms. Right? I put them in parentheses. And then it's just a matter of simplifying. So again, what should happen is we're going to do a bunch of canceling. And the goal is that the fractions will be gone after we do that. So go ahead and do that. Go ahead and simplify that, try to do some canceling, and see if the fractions go away. Here's what you should have had with your canceling. Okay? Here's all my canceling. Okay? On the first one, the P minus 2's cancel. So I don't have a denominator anymore. There's technically a 1 here and technically a 1 here. So there's no denominator there. In the second term, they both cancel. So I'm just left with this 2P plus 1. This last one, the P plus 4 cancels. And notice I've circled the P minus 2 and the 2 because I'm going to have to multiply those. I'm going to have to distribute that. Okay? So now I want to rewrite this problem a little cleaner after I've done all my canceling. So P plus 4 times 1, of course, is just P plus 4. Over here, the only thing left is 2P plus 1. What am I going to get when I multiply this out?
2P minus 4.
Okay, good. So this is what I'm left with. So now I've got an easy equation, no fractions. So go ahead and solve that equation. Now, so that's where you should have gotten, and then it's just a matter of solving. What does P equal?
P equals
7/3.
7/3.
What?
P equals 7/3. Okay? Now, let's go, before we move on, we've got to check something. Okay? What values in the original equation can P not equal? What values for P will create a problem?
2.
2. 2,
And negative 4.
if P is 2, that makes this 0. That's a problem.
That would be.
If P is negative 4, that creates us as well. So my values, P cannot be equal to 2 or negative 4. And if you want, you can identify those at the beginning, almost like doing the domain. Okay? My answer is clearly not 2 or negative 4, so there's nothing wrong with my answer, which means that's my answer. And I'm done. Do you have to write this down? Not necessarily. But what I would tell you is if you do write it down, it's easier to identify whether or not you have a problem with your solution. Okay? I chose to, this is my check. My check is basically saying P can't equal 2 or negative 4. Look, is this 2 or negative 4? No, so it's good. That's my check.
So if it's 2, then what would it be?
Right. If this would have ended up being 2, I would have thrown it out and I'd have no solution.
Okay.
Okay? Or if you have for example, if you have multiple solutions, which can happen, and one of them is one of these, then you would throw that one out. Yeah,
So from the beginning, you can't just say 2 and negative 4.
you could. It can't be 2 or negative 4. You could say that from the beginning.
But you still have to solve it.
Yeah, you still have to actually solve that. All this is saying the values that P cannot equal.